Welcome, everyone, to this Observable Lightning Talks, the June edition. If you followed, we have several editions since a couple of years now, inviting different people, different guests to this Observable Lightning Talks. If you're connected, well, first of all, welcome to this live stream. So, we're going to spend about an hour and probably 10 minutes, 1 hour and 10 minutes in total. If you're connected, probably you're connected from LinkedIn, Twitter, X, sorry, Twitch, or YouTube. You can basically drop your questions and you notify us where you're connected from. So I'm connected from France, south of France, exactly. And I will be very excited to present this new edition of the Observable Lightning Talks. And for those who never heard about the Observable Lightning Talks, let me remind you the flow of this live stream. So this live stream will be basically, we have different sections. We will have in total 3 lightning talks, which means 3 presentations of 15 minutes. And those presentations will cover the topics that we cover usually in the YouTube channel, which is observability in general, security or Kubernetes related. Today the talk will be mainly related to observability and security. And last, we will have a panel discussion at the end. During this panel discussion, it's basically the Q&A, because during the 15-minute talks, we don't ask questions, we just note them. And then at the end, we have like a panel discussion where we exchange and we share our thoughts about the different topics covered today. So what is the actual agenda of today's live stream? Well, we'll have 3 lightning talks, and I'm very excited because today I have the chance to invite 2 customers or 2 end users that have implemented quite a cool use cases. And we will start with Alexandre Magno. He did an awesome presentation in KubeCon Europe Paris about tail sampling. And I thought, yeah, what about the best way of educating people by sharing best practice about tail sampling with the collector? I think it will be fantastic. So if you are interested in tail sampling, wait a few seconds or minutes. Alexander will walk through the tail sampling experience that he has within his organizations. And the second presenter is Thomas Labostion. Is from Sysdig, and he is the senior DevRel advocate at Sysdig. So Sysdig is the company providing Falco. So obviously he will talk about Falco. So if you're interested about Falco, the features and the different components that are involved in Falco, check it out. He will talk about this in probably in 50 minutes. And last, we have Gabriel. Gabriel is, we met as well in KubeCon Europe in Paris, and he implemented a really cool solutions. If you remember in this channel, we talked about the SQL commenter a year or 2 years ago, which was a project donated to the OpenTelemetry project that was initially launched by Google Cloud. And now the SQL commenter is there, but not really utilized in most of the environments. And what is cool with Gabriel has implemented something pretty nice where you can basically get some tracing out of PostgreSQL. And I'm really, really eager to see that in action. So be patient. He will walk through that and probably going to share a demo as well. So without waiting anymore, I think it makes sense that we start with the first presenter, which is Alexandre. Oh, hey, hi, Alexandre. How are you?
Hi, my friend. I'm fine. Very, very good, and a big pleasure to be here with you.
So where are you connected from?
Yeah, I'm based on Brazil, São Paulo city, and today is a good day, sunny day here, and we are near of the lunchtime here.
So you're more than wake up. So you're have the full energy to to rock on stage and present tail sampling for us. So that's awesome. I'm very eager to that. So I think, yeah, I will let you take control on the stage for the next 50 minutes. And so good luck and yeah, enjoy and see you in 50 minutes.
Okay. Hi everyone. Today I'm here to do a presentation about tail sampling. It's a similar presentation that I did on KubeCon Paris with my friend Juraci. Juraci is a maintainer of the tail sampling, of maintainer of the OpenTelemetry and some features that is there. He's a genial guy and a big pleasure to be there with him. I speak a little bit about me. I am manager of SRE at Pismo, and my background is in infrastructure, and I have worked with SRE and observability on the last years. And I'm in this journey about technologies and infrastructure, SRE, something about 70 years. And so I saw a lot of things during this journey. Well, first of all, to talk about the sampling is necessary to say why we needed sampling at Pismo here. So just to provide a little bit more context about the Pismo, Pismo is a provider of banking as a service and has large customers, big banks around the world. And we are under exponential growth. So there are a lot of millions and millions of transactions passing for our platform. And with this exponential growth of the company, we hopefully without exponential observability costs. So this is the challenges that we have here. And to provide some kind of control in terms of observability, we cannot lose visibility. So it's necessary to keep visibility of our servers. So with all these topics, it's bring to us a big challenge here. How we can provide a good observability traces and in terms of trace and um, provide a cus that makes sense. The cus cannot explode in terms of the tools of that we use to flow the behavior of the services here. And here is one the main things that why we need of the sampling to implement sampling. Our cost was growing very fast and was becoming very expensive to keep the service of observability traces in this case. So with it in mind, it was necessary to take some actions and how we can control this without loss the quality. In that moment, we need to take some actions that I will share with you with more details on next slides. But just to provide more context about sampling, maybe there are someone that is not familiar with this topic. Sampling is a technique that we can use to reduce amount of telemetry data that is generated and is stored. So here is the good point that is similar this picture that is on the slide. You don't need to eat all the fruits on the tree to understand the flavor and bring it for our words here. You don't need to store 100% of the traces of the spans that is generated in your transactions, in your applications, to understand the behavior and provide a good observability. You can perform a sampling using some strategies to provide a good observability and with enough data to analyze when necessary. The point here, in the moments that we choose to implement sampling, we had two options that was considered in that moment. So the main options that we had in that moment was about the head sampling. Head sampling is a technique of sampling that has some kind of problem that we discarded this possibility for one reason. For example, when the transaction is started, the decision to store this data or not is taken on the beginning of the transactions in head sampling case. So it can bring some kind of problems to us because we want to understand the full context in the moment that some problems can happen. So we've had sampling. The problem is if the decision is taken on the beginning of the transactions, you can discard relevant data. For example, some transactions that get error and can be discarded. So you won't understand what happened with that transaction. So we choose to tail sampling. We choose tail sampling because tail sampling there are possibility to implementing some policies and where you can choose what you want to store or not. So it provides to us a good visibility in terms of the crash when the crash happen in the application. You will provide a good visibility for your developer or for someone that is providing some kind of troubleshooting because the data is there with errors and you can implement in policy based in high latency. For example, you can set a minimal latency to be stored or not. And so imagine that for some reason the transaction is taking a long time. If it pass for a specific threshold, you can store this data to understand the behavior. What is the step that application is taking a long time? So there are a fine control in terms of the policy that you can use with tail sampling. And another point is tuning, tail sampling and OpenTelemetry as well. There are a lot of metrics very relevant to analyze when you need to understand the behavior of the OpenTelemetry Collector. For example, you can understand the rate of spans that you are receiving, the rate of spans that you are sending for your tool of that you are storing the traces. So the logs is very good too because provides a good insights in the logs and the metrics. So for you provide some kind of tuning based in data is very useful to use the metrics and logs of the OpenTelemetry. And for in our journey here was very useful to use these metrics and logs. Uh, Tail sampling allow us to control observability costs because how we are growing fast, the costs of observability maybe can be impacted. So eventually, if the costs of observability grow very fast and without some kind of control, it can impact the margins of the product. So the idea here is keep the quality, speed, efficient, and cost keep it under control. And the good point here is about the tail sampling is that you can control the cost, but this kind of control cannot impact the visibility that you need to have in your service. When problems happen, you need to have a maximum of data to analyze, to understand the problem, and provide a good solution in the short time. So this is the possibilities that tail sampling allow us to do. Here is a diagram that we have implemented here. For example, all our applications is instrumented with OpenTelemetry SDK, and 100% of the trace is sent to our collector. In our collector, we analyze and apply some policies using tail sampling and decide if we want to store this data or not. So we send just the necessary data to our backend. So it's provide to us a good save in terms of the cost of observability because we will be stored just necessary data, not 100%, because sometimes 100% of the data can be very expensive, for example, in our case. Uh, Here we have some policies that we have implemented here in our collector, where where I have, for example, if there are some error in the transactions, this trace I want to store. So this is the first policy that we have here. And another point is maybe there are some applications that you don't want to implement sampling. You want to store 100% of this trace. So it's possible to implement it too. And another policy is if there are some transactions that is with high latency, you in our case we are considering 5 seconds. I want to store this data to understand what happened for this transaction is taking a long time. As we are banking as a service with uh, instant payments and the transactions, a lot of money every time, the response time of the application need to be very fast. So 5 seconds to us is a high response time. And another policy that we have implemented is probabilistic, where we start 25%. 25% we consider that is a good number to understand the behavior of the application. So what is the idea here? If I don't have any problem, any issue in the environment, I will store until 25% of the traces that is being generated in our platform. But if I have error, high latency, or some application in the exception rule, I will try to store 100% of this. I say we will try because imagine that we have a big incident, so the collector will be flooded with traces, and maybe in this moment can be a problem for the collector, and it can restart. But until restart the collector, we have a lot of data stored to understand what happened in our environment. Another session of a tail sampling is how much time I need to wait to take a decision. In our case, is 5 seconds. We wait for 5 seconds to understand if that trace has some kind of error, high latency, exception rule, and after this we will send for our tool of that we are storing our trace. And the number of the trace that we can keep on the memory of the collector is 120,000 spans in the memory. That is the count of traces that we can keep on the memory to take a decision if we will start or not. And here we have example of the dashboard that we use here. That is in this first graph, we have the total of spans that the collector is receiving, and in the second chart, we have a total of spans that we send for our provider of the tool of observability. So the number we can see that is less than we are receiving. So it provides to us a good save in terms of the costs of observability. And here I have an example of the costs that we have now after to implement the tail sampling in our environments. And we were paying almost $18,000 uh, by month. And after to implement tail sampling, we could reduce a lot these costs, and because we can realize that is controlled because we don't have big spikes of the costs of observability. In our first deal with the tool that provided the service for us, we have a deal for 3 years to use the tool. But with the volume of spans that we are sending, this deal was finishing in 11 months. So it's a point that triggered the us to take some actions to solve this kind of problem. And here we have some next steps that we are testing already the load balancer and implement ATPA to scale our collectors because we have some environments that has a high volume of spans generating every time, every moment, and we need to scale it dynamically. So with load balancer, we can achieve it, and we are already testing this. But the version of that we are using now there are some issues in terms of the performance and is consuming a lot of resource on load balancer. So we are upgrading for the stable version of the OpenTelemetry that has some improvements in terms of the resource utilizations, and we are implementing here load balancer of the OpenTelemetry and ATPA to be more scalable services. So it's a very fast things that I shared with you guys, and it's brief, and we can cover more points during the talk here. And thank you.
All right, thank you, Alexander. Very interesting. I have a couple of questions to be honest. I looked at the settings, but I will keep those questions later. So same thing. If you watched the presentation and you have questions in mind, just note them down or drop them already in the comments of YouTube or X, whatever, and we will cover those questions later in these observable lightning talks. All right. So thanks a lot, Alexander, and let's move on to Thomas' presentation. See you. Hey, Thomas. How are you? Oh, Thomas. Oh, oh, we don't hear you.
Okay. Oh,
Oh, no, we don't hear you.
is it better or not?
Ah, it's much better. It's much better.
Okay,
Now we can hear
strange. My mic was out, but okay.
So, Thomas, where are you connected? Bordeaux, I guess, or close to Bordeaux?
Yeah, directly from Bordeaux, France.
Okay, so how is the weather today? I mean, here in south of France, it's pretty hot at the moment. I don't know how is
Yeah,
Bordeaux.
exactly the
How
same.
is Bordeaux?
After weeks and weeks of rain, it's getting hotter and hotter. It's hard to resist to that heat wave.
So, for those who never heard about Thomas, Thomas is a developer advocate, senior developer advocate at Sysdig, and Sysdig is the main contributor to an open source project that is available in the CNCF landscape, which is Falco. Falco has lots of different features, and I think you was one of the initial contributor to the Sidekick UI and Sidekick component. And are you going to
I
share some
created that,
assets about
yes.
it, or cool?
Yeah, I will
So, going to
present these two because they are part
all
of
right,
the
awesome.
ecosystem. So I will.
Okay, cool. So yeah, so I will leave the stage to you, and yeah, good luck, and see you in 15 minutes.
Right, thanks. So I will try to respect the 15 minutes. Not easy. I have a lot of things to say. So tonight I will introduce to you Falco and its ecosystem. What is its purpose, what to do with, what we can detect, how we detect things. So first we have to understand in which scope Falco evolves. Um, it's a tool made for runtime security. Basically, the idea is to detect suspicious things, strange behaviors in real time when they happen. So it's a tool made to uh, create security for running applications. You can consider that like basically a security camera to detect things that may happen. So Falco is a graduated CNCF project created by Sysdig. The first contributor, original creator, is Loris DeGiovanni. He is also one of the creators of Wireshark. So Falco is a cloud-native project to detect threats in Kubernetes, but not only. As long as you have a kernel Linux, it can work. So we'll see it's also possible to collect other sources of events thanks to plugins. Just before the last KubeCon, we got the graduation, so Falco can be considered as the most robust, the most resilient project for runtime security. You can find out in the CNCF landscape. The first source of events are syscalls. So just to be sure everyone is aware about what syscalls are. When an application needs an access to some memory, to some cycles of the CPU to do calculation, to open a socket in your Ethernet card, this application will ask the authorization and the access to the kernel. This request is made through a system call, a syscall. You can consider that like the API of your kernel. So if you are able to collect these syscalls, the answer and the response, technically you can see everything that is happening inside your system at the lower level, the lowest level. And this is exactly what Falco does. Thanks to eBPF, we collect these syscalls and then we enrich them with some metadata. These metadata it's pretty easy, the container ID, the container name. If the process is running inside a pod, we also have the pod label, the pod name, the pod namespace. All these informations that are relevant for us, humans, to write rules and to know the context of the events. If you are running a kernel above 5.18, I think, you can also use our freshest probe using the Cori paradigm. Compile runs run everywhere. So basically, you can run Falco with the eBPF probe like a snap. Falco is basically a rule engine, so it collects these events from the kernel with the eBPF probe and compare all these events with some rules. This is an example of a real rule for Falco. So we have a name for the rule field, terminal shell container, a description for us to understand what is the purpose of the rule, and condition. If this condition matches with the event, an alert is triggered, and an output. This output is exactly what we retrieve at the end in the logs. And you can see some fields beginning with a percent sign, percent character. Basically, all these fields will be dynamically replaced by Falco to give us some context. So you can see user.name, user.login ID, proc name, pname, proc name. Even if you're not familiar with Falco, even if you're not familiar with the syscalls, with the lower level of Linux, you can understand easily what we are talking about. Everything is made to create easy to extend, easy to customize user experience. You also have priority tags and so on. This condition, in reality, is made of in that situation of macros and lists. Why? Because some rules, for example, if you want to detect the creation, the bootstrap of a process, you don't have to write the exact condition over and over in all your rules. You can reuse one of the macro we provide, and you can create your own. And it's much easier to read the rules, to extend them, and to improve them. So we have these blocks called macros, and these macros can also use, and also the rules, the conditions, you can use lists. As everything is written in YAML, you can easily extend or customize the rules, the macros, the list by just overriding the conditions, the items or else, or just appending elements. Of course, you are not alone in that situation. You are not alone with Falco. We know it can be tricky to write rules at the beginning. So the community and the maintainers provide a set of default rules. We are trying to cover as much as possible attack patterns you may find out on the wide internet. So, for example, privilege escalations, the data exfiltrations, the mutations of binaries, so crypto miners, ransomwares, and so on. On the right in the square, you can see how to customize the default rules, default list, default macros. It's easy, so you can use default rules and just create a small block to customize them in your CI with your CI files. This is an example of what kind of rule we can receive from Falco. Either you keep the raw format, it's just a log line, or you can choose to have a JSON payload. With the JSON payload, you have much more details. For example, you have the output, the priority, the rule, the source, also the host name, and you also have the output fields section in the JSON payload. This section contains all tokens that have been replaced to create the output. So if you have another system after, it's easier to filter on the port name, on the namespace, the container name, and so on. I told at the beginning we are collecting syscalls from the kernel, but that's not that only. Thanks to plugins, basically Falco can ingest any stream of events you may have. For example, this is how we collect the control plane audit logs for Kubernetes. In case you are using a managed cluster, EKS, GKE, AKS, OpenShift, or else, we also have plugins to retrieve the logs from the blog storage system of the cloud provider. Right now we have EKS and GKE, but in the future we'll have AKS. We are working on that. We also have CloudTrails for Amazon, GitHub Webhooks, Nomad. So we developed that plugin with HashiCorp directly. Okta, Docker, Bitcoin. It's just something to demonstrate we can subscribe. Falco can subscribe to any WebSocket and get events like that, and also set forth. We have other plugins. Take a look on the plugins repository on GitHub. The links are at the end of the presentation. And if you want, you can create your own also. So the overview of the Falco architecture is that we have the syscall collections from the kernel with the eBitpref prod. We can collect events from other systems thanks to the plugins. We are ingesting the logs, rules to Falco, and Falco can then trigger an alert and forward this alert to the standout file program, basically it's pipe, to a syslog, local or remote syslog server, HTTP, like a webhook, and gRPC. If it's not enough, we also have Falco Psychic. Falco Psychic basically is a proxy forwarder between Falco and your ecosystem. It allows you to collect Falco and retrieve the events and forward the events to a chat system like Slack, Discord, Teams, or else. If you are using a SIEM like Elasticsearch, you can use it. For course, we have Loki, Quickwit, Smologic. If the amount of events is really big, or you want to mutualize some systems, you can also use queues like Kafka, NATS, PubSub, or else. Of course, you have metrics with Prometheus, and you can also wake up your own call with PagerDuty, Obtain, Grafana on call, or else. Right now, we have not 65 integrations, made something like 71. The new version of Falco Psychic is coming next week, normally. So stay tuned. Falco Psychic comes also with a basic UI. So if you don't want to connect Falco to your existing ecosystem, to your existing Elasticsearch, for example, you can just enable the UI of Falco Psychic and get an overview of what has been detected by Falco, tune the rules, because of course you have to adapt the list to your ecosystem, to your own environment. And then when you are confident, you can plug anything behind. So basically, we have this overview for Falco Psychic, and the UI. The last stage is we have the detection with Falco, we have the notification with the UI. The last logical step is to react. In Falco Psychic, we have the integrations of some serverless functional services, Lambda, OpenFast, Knative, or else. But it works pretty well. We wrote a series of blog posts to explain how to set up that, but it's not really convenient if you are not familiar with Lambda, with OpenFast. You don't have the infrastructure to deploy them, the CI, and so on. So in the Falco community, we started a new project called Falco Talon. Basically, this is a response engine perfectly made for Falco, so it can understand the Falco payload out of the box, and you don't have to write any line of code. Basically, Falco Talon will receive the events from Falco directly or from Falco Psychic, and you will give it some rules like we do for Falco. And these rules will be in charge to not this time do the correlation between, they will do the correlation between an event from Falco and actions to perform. And you, out of the box, you have notifications, you have logs, metrics, and so on. So you don't have to write rules, to develop the code, like I said. You can reuse what we call available actioners. They are on catalogs. So out of the box, you can terminate a pod, label a pod, create a network policy, execute a command, or run a script, get the log, delete, and so on. For delete, it's everything that is not a pod, so a network policy, a config map, a secrets, or else. You can also create a Calico network policy, a Cilium, and trigger a Lambda also. You can do the correlation over any element from the payload, the priority, the tags, the source, the rules, the output feeds, everything. And the actions can be sequential. So basically, you can, for example, get the log of the pod, call down the node, drain the node, and then run a Lambda to destroy the EC2, for example. We have structure load and so on. I'm moving on because only 1 minute left. This is an example of what kind of rule we can have in Falco Talon. This is the same idea. In Falco, we have the macros. In Talon, we have the action blocks. So you can reuse one action block from one rule to another. In that situation, for example, we do the correlation. We have a match if Talon receives an event concerning the Falco rule called right below etc, but the namespace is not the concerned namespace is not cup system. First, we get the logs, then we open the file detected by the Falco rule, and then we terminate the pod, except if it's a daemon set, it's part of a daemon set, of a stateful set, and if we don't have enough empty replicas. And you can see, to get the log, we can also export this log to S3 after for investigation, cold investigation, to write incident report or else. So basically, if we have a global picture of the Falco ecosystem, we have the orb to collect the syscall, we have the plugins to collect anything, any event, Falco Psychic to display or to forward the events, and Talon to react. I wanted to do a demo, but I only have 10 seconds remaining, so I will skip that. If you want to start, take a look at the links I can share with Hendrik after the slides, and everyone will be able to click on that. I think I'm good with the timing now.
Yes, you are completely good in timing. So first of all, so a few links. You mentioned Falco, so here's the QR code for the Falco project if you want to get more details. And you mentioned also another one was Falco Psychic UI. So if you want to reach out to the Falco Psychic UI project, the GitHub repo, scan this QR code and you will have access to that. And last, really interesting, so I have questions about this one, by the way. It's the Falco Talon, very interesting project. I was not aware of that, so very interesting. And yeah, I will keep my question for later because otherwise it will take too much time to answer those questions. All right, so Thomas, thank you so much for your time and for your presentations. And let's move on to the next last talk of tonight, which is the talk from Gabriel. So see you in a few minutes. Hi, Gabriel. How are you?
Hello, Henrik. Can you hear me?
I can hear you very, very well.
Great. How are you?
So, I'm good. I'm very excited to have you here. Especially, I'm very eager. Sorry, very eager to see what your implementation. So, where are you connecting from?
I'm connecting from Winterthur, which is in Switzerland, in the eastern part.
So, how is the weather in Switzerland?
Well, this morning here it was raining a lot, but it cleared up in the afternoon, and now it's pretty hot actually, and it's also pretty hot in this room. I mean.
All right. So I'm losing my voice. So I'll let you present for 50 minutes so then I can recover my voice for sure. So
Yeah.
Good luck. Leave the stage to you and see you in 50 minutes.
Thank you. So I'm here to talk about PostgreSQL and tracing requests to PostgreSQL from the application. As Henrik mentioned before, this is not a completely new topic. Google has the ability to do this if you use Google Cloud SQL. But if you run your own PostgreSQL database, if you run PostgreSQL database on some other cloud provider, you don't have the ability to trace requests from the application to the database and see how they belong together. So I'm going to present how I did it for PostgreSQL if you run it yourself. And I think we can also learn something about other things, other databases and other tools that are not databases, how we can maybe include traces for these tools as well. Who am I? I am Gabriel Koch. I'm product owner for the cloud platform team in AXA Switzerland. We are a large insurance company in Switzerland, and we have about 300 software engineers in Switzerland delivering software for our business on our platform. All right. So why is tracing for PostgreSQL a challenge? Well, first of all, PostgreSQL does not support tracing out of the box. So we have logs from PostgreSQL, but these are inconvenient in my opinion. And I think if we can do tracing, it would be much more convenient, would be much easier to connect issues that we have in our application with their root cause that may be in the database. Or also we may be able to exclude the database more quickly as the root cause if we have traces from the database as well. Now the problem is we do not control the source code or runtime for PostgreSQL. It's written in C, and you cannot just instrument it easily like you could with a Java or Node or .NET application, something like this, with the OpenTelemetry libraries or agents. So we have to find another way to do it. And databases are really important for most of our applications, at least in AXA Switzerland. That's why I want to correlate telemetry from the applications with the telemetry that we have from the databases. So two main challenges we have when trying to trace, to extend tracing to PostgreSQL. First of all, we want to pass context. We have to pass over the trace parent information to the database so that we can then generate trace spans that are correlatable with the trace spans from the application. And the second challenge is, well, we don't have trace spans, as I mentioned, so we have to sort of find information from PostgreSQL and generate trace spans from that. All right. So the first challenge is pretty much solved. As Henrik mentioned, he presented the SQL commenter on the Is It Observable YouTube channel a while ago, and I think that was pretty good. I also learned about it from there. And what it does is it embeds trace parent information in comments on your SQL query. So you can see it here at the bottom. You can see in this code snippet, this is a SQL query that was generated by my application, which uses the Next.js SQL query builder. And if you use the OpenTelemetry SDK, it has the SQL commenter integrated, and it automatically adds the trace parent information as a SQL comment here at the bottom. So we have this solved. We pass this information down to the database, and now what can we do with it? This is a really funny screenshot that sort of illustrates the problems that we now have. So we now have the SQL trace information, the trace parent information on the database, and now we can generate logs from it, right? That include this trace parent. I have highlighted here a couple of times the trace parent information from the database logs or in the database logs. But there's some problems that we still have with it, because first of all, the PostgreSQL JSON logs aren't very JSON native, in my opinion. We can see down here in the orange section, this is the query plan that we may be interested in, and it is a JSON object that has been string encoded and put into another JSON object, in a property in another JSON object. But it starts with duration, colon, something, some number, ms, then plan, colon, and then starts a query plan. So it just forces us to do a lot of string processing on these logs to even get this information out. And what are the interesting information that we might want to get from PostgreSQL regarding our queries? I think is the query duration, certainly. Query plan information, as I mentioned, and on the query plan we get a lot more information as well. If we configure it correctly, we can get information about how many cache hits do we do when accessing a disk or before accessing a disk, and well, how many rows are scanned, etc. And I think that helps us finding out if we have a bad query that performs well or badly in certain cases. And I think these are all the information that we want for in our observability system, certainly, and in our tracing system, maybe, to be able to debug potential issues more quickly. Okay, so we have this log information that contains all the stuff that we want, and we have to do a lot of pre-processing or log processing for sure. So can we just put it into traces as well? I thought, well, it shouldn't be that hard. And I looked into it and I tried to build a prototype. Let's see how that went. First, I decided to check what options do I have, how do I do this processing pipeline. And on this slide on the left, we can see there's a PostgreSQL database. It writes a JSON log file, or it streams the JSON logs out. And then I could write a component, this one highlighted in yellow or orange, that takes these logs from PostgreSQL, reads them, parses them, does the JSON parsing, etc., and then writes them as traces to a backend, such as the OpenTelemetry Collector or directly into a backend such as Jaeger. This is certainly one option, but I looked into other options as well, because I think, parsing JSON logs, I don't need to do this. And the OpenTelemetry Collector, for example, can do this already. So I looked into the OpenTelemetry Connector features. I thought maybe we can build it in there somehow. And they have introduced last year the OpenTelemetry Connector API. The OpenTelemetry Connector is a API or a component that can exist within the collector and that connects two pipelines. So for example, it can be used to connect the traces pipeline to the metrics pipeline to extract, for example, request duration, request error rate, etc., things like this that may be available on traces already, and generate metrics from those. And this is, I think, is a good way to extract metrics from traces, because then you don't need to scrape metrics from your application separately. But I thought, well, maybe I can use this to process logs with the OpenTelemetry collector, then build a connector and extract traces from those logs with this connector. And if we do this, we have some benefits. For example, we can use all the other capabilities that are already in the OpenTelemetry Collector, right? It has a lot of receivers. It can ingest logs from Fluentd, from anything. Usually you have it already set up, right? And it has a bunch of pre-processing or text processing features as well that you can use to pre-process your logs that are coming from PostgreSQL. And then you also don't need to care about exporting. You just need to figure out what is the information in these logs and how can I do extract traces from that. That looks a little bit different than from the diagram before. We stream the JSON logs into an OpenTelemetry Collector, then handle that, and then push it maybe into another OpenTelemetry Collector or not. So I want to quickly show how this works, and I have it set up here quickly. So we have a Jaeger UI here, and I have a little example application running. I can do a curl to my application. I don't know how the syntax is anymore. And if I do this, it says hello from Express server. Actually, let me zoom in a little bit. Hello from Express server, right? I can also access an API. Yeah, a cart API that says, well, I have this one product 20 times in my shopping cart. So it is a little shopping cart application, very simple for demo purposes. And it reads this from the database, right? So now we can go to Jaeger, and we should see that these requests have happened just before. And I can see, well, down here, I have 2 requests to the root endpoint on my app. It spawns or it generates some spans for Express middleware, and that's it. And then I also have the request to the API/cart endpoint. And here I can already see I have 2 systems that contribute the trace spans to this trace. And I can see, well, first of all, there's some more stuff happening in Node in the Express server. I can see there's a query being built. This is actually from the auto instrumentation for Next.js, the SQL query builder I used in this case. And I can also see the trace span. I can see the trace span for the PostgreSQL connector. And then I can see down here, these 5 spans down here are from the database themselves. And here, in this example, I extracted the trace, the query plan, and each node of the query plan I extracted into a separate span. And I can see, well, here has a sequential scan happened. It has happened over the cart item table, and well, I have all this information about how many cache hits did I do, how many, yeah. So all the information that you can get from a query plane in PostgreSQL. And I think it's pretty good to see already on one glance that the database is super fast. I need to. The database is super fast. So this takes 1.8 milliseconds, and the whole connection to the database, the network stack on my device actually takes a bit more time. I'm not sure why exactly it is so slow, but it is a bit slow in my opinion. And I think that gives you a pretty good overview if you have a problem, for example, a performance problem, whether you have a network issue, or whether you maybe have a database issue, or whether you have some bad queries. And if you have a bad query, it can already tell you, well, what part of the query is bad. All right, so that's it from the demo. And let me wrap up quickly. So in conclusion, use the SQL commenter functionality to send trace parent information to your database, and then you can either just consume the logs, or you can then also use something like the connector API in OpenTelemetry Collector to build a custom connector and generate traces from logs. And I think that is something that's usable for other systems as well. And I think it's pretty easy. In this case, it's still a demo. It's a prototype. If you want to have a look at it too, but don't deploy it in production. All right, that's it from me. And you can find me on here.
Oh, let me open the slide again.
Yeah.
Awesome. So you have the PG trace connector. Awesome. This is actually was one of my next questions for the panel discussion. So I will try to copy it and put it as a if you can send me on the private chat, I will put it as a QR code later so people can scan it and have access to it for sure. All right, so thanks, Gabriel, and let's jump into the panel discussion. So see you in almost a few seconds, honestly. All right, see you. Hey, first of all, thanks. And a good team job, all of you. Alexander, you were almost there, but I was expecting that you were going to conclude, so I didn't interrupt you, but you did an amazing job for sure. So again, for all the people listening, keep in mind that you can drop your questions. So please drop your questions. We have the next 15 minutes. We will answer to Mike all the questions that we have between us. But also, if you have any questions in your mind about any one of the presentations that has been presented today, please feel free to drop your questions, and we will cover those questions as well during the Q&A. So let's start with the first presentation, because the first presentation was actually Alexandre. So Alexandre, tell something is a huge topic, and you presented the policies. So I briefly played with it, but I'm not as deep as you did. And I was wondering if you have you had I don't remember in the example you had 1, 2, 3, 4, or 5 rules. I don't remember the number of rules, but how is it? Is it or and? Is it exclusive? For example, I only take the errors, but if the application is there, it will be also sampled, or how does it work?
That rules is not a sequential rules or nothing based in it. Everything that pass for these rules. For example, we have a time to take a decision on tail sample. For example, all traces that I receive, I will keep in the memory for 5 seconds, and we have more than 100,000 of traces that can be kept in memory. But after this, we wait for 5 seconds, and will be analyzed if Oh, this trace, there are some error. Yes, there are. So we need to sampling it to send to tool for our tool. There are some high latency. For example, the time is 5 seconds or more. Yes, I need to store this trace. But if you don't have nothing happen in these transactions, will be consider the probabilistic rule. So we can send until 25% of the trace that is being generated in our platform. This
So
is the
so at the
rule.
end, if
So
so at the end, so at
the,
the end, if you are above the 5 seconds delay, then you will pick the 25 probabilistic sampling as well. But if I
exactly.
remember there was a rule where you say only the service this service will be sampled. We don't we take 100%. But if does it also include the rule where it says if the response time is above 5 seconds, or I don't remember the exact timing that you set on the response times?
Yeah.
Is it combining the rules, or is just this app whatever 100%?
Wherever, yeah. If this rule, if the application is in that rule, for example, I don't want to perform discard nothing about this application. I want to store everything, so that rule will do this. So if I arrive some transactions that it's a distributed tracer, okay. So if this application is involved in the transactions, all traces that application is involved will be sent for our tool.
And other thing that I had in mind when you presented is I know that time sampling. Obviously, you send a lot of spans, and then the collector is queuing them before making the decision to sample or not. So there is obviously an impact on memory. So have you measured the actual impact for the memory usage on the collector? Is
Yeah. For example, using the tail sampling, how we have to keep the traces on in the memory. We need to provide a lot of memory for the collector. But when we compare the volume of money that we are saving and the cost that we have to provide more memory for the
yeah,
collector,
it's not.
this kind of uh, count makes sense for us to keep the more memory for the collector. But to solve this kind of problem, and in our case, we provide more memory for the collector for exception, because during the night there are some process that run and generate a lot of spans during the night. So during the day is not so used in terms of the resource of memory and CPU. So we can scale it for down. For this reason, we are implementing the load balancer. For example, I have a load balancer where if I have a high volume and the collector is starting to use high memory or CPU, I can scale it and provide a new collector, and scaling it horizontally to provide more resource. But if I don't use if my environment don't have a lot of trace in that moment, I can perform scale down and use the uh,
Okay.
few resource in terms of CPU and memory.
I know that a lot of people is doing a lot of analytics with the generated trace. Specifically, sometimes there's a lot of details that are pushed through the span events, and I thought, yeah, let's try to build a connector like Gabriel did, where I get the actual trace before I sending to tail sampling. I get the actual trace, and then I'm extracting those events that I need for analytics perspective, and then those will be sent into logs or events because OpenTelemetry events is there, and then make the sample. But otherwise, I thought if I sample, I'm losing 25%, and there's always those boundaries where when you are specifically in performance, you want to see the very fast transaction and very slow transactions. Have you thought about using the span metrics connector where you can basically extract the analytics from the spans produced into metrics? So then you are sampling and you just get a sample version of the traces, but you still have the analytics on the response times.
We have the trace for us is a part of the observability. We have another metrics, custom metrics that can provide a good insight for us to analyze the behavior of the application. So I have we have a good strategy in terms of logs. For example, logs that we have here. Sometimes it's a lot of logs, but the strategy of logs that we have here. And when we start some application, we get the correlation ID and put this correlation ID in all line logs that was generated by that transactions. For example, the transaction started in application A, B, and C. The same correlation ID will be
Pushed in
tagged
the
in
logs.
all line logs. Yes. So we if we need to analyze some behavior, some kind of problem, we can use this correlation idea and analyze the logs. But when we want to understand more deeper some situation, we can use the trace because, for example, if this transaction has some kind of error, okay, we know that we have logs, and with based in it, we know that we have the the full trace of these transactions, and we can understand better what happened there. And we have a good metrics too. For example, we have metrics from container and nodes and understand the full environment too. We have some dashboards where we can analyze the capacity planning and golden signals that to get provide for us good insights to understand the behavior and when the problems happen it started, for example.
And the last question was within this number, you're 75K, I think, and then it was 12K something. Did you only include the cost of the traces, or was it global for metrics, traces, and logs?
I perform some optimizations in terms of metrics too, because there are, for example, when we check the issue metrics, for example, there are some metrics that has a high cardinality. And another point that I consider here is, for example, the label that is set in the root of the label. For example, imagine that you have 10 millions of metrics in your Prometheus, for example, and you have um, a label that is propagated for all metrics. We analyze this label is really necessary. If it's not necessary, we can drop,
Yeah.
and it will reduce a lot of. We have in the past, in terms of metrics, we have some labels that we set in the each metrics that we have because it's relevant to us. But the agent that we are using that moment was creating uh, a, a label with the same value that us, but with another name. For example, we are using the cluster label that has a name of the cluster Kubernetes. And there are another label that was agent, but the value of this label agent is the name of my cluster. So I don't need of
It
this
does make
label.
sense.
I can
Yeah.
drop. And millions and millions of series inside of Prometheus was reduced. And some we analyze a lot the metrics that we are putting inside of the Prometheus, because if it's necessary, okay. If it's not necessary, we can drop. But about the logs, yeah, we have a lot of logs here, but it's a big fight to that we have here because the developers love logs to understand the full context of the application, but it's not necessary to be a debugger 24 hours a day.
Yeah, agree. All right, thanks, Gabriel or Thomas. Do you have any questions for Alexandre?
Yeah, I have one. You mentioned that you're scaling the collector. I think with tail sampling, it's hard to scale horizontally, right? How did you solve that problem? Because
Yeah,
you
nice.
have some trace spans for the same trace coming into one collector and some for the others, they need to talk to each other, right?
Perfectly. Good question. The OpenTelemetry Collector has a feature called load balancer. So when you insert the load balancer in your architecture, all traces will be sent for load balancer, and load balancer will choose the collector that will receive the trace. So all traces that is generated for one transaction will be sent for the same collector every time until this transactions finish. But there are a hash consistent algorithm that the load balancer has, and he can understand what is the collector responsible for specific trace ID. All traces will be sent for the same collector. It's a good point for and a good
So,
good question.
so this is why you mentioned that there were some performance issues with the load balancer plugin of the collector. Maybe after a high number of transactions, those hash is exploding, or
I didn't face this problem yet. We are doing a POC here, but the problem that we have was related resource that load balancer was consuming. So was staying a little bit more expensive that we are waiting. But thanks God I have a good contact with Juracy that is responsible for this component. And when I need something, oh, Juracy help me. And we can open a ticket for my friend. And
so you have the red line. Yeah,
yeah,
yeah, yeah.
yeah. And uh, but I didn't talk about it with him, but I saw some threads that he was speaking in the Slack on the channel of OpenTelemetry, and we saw that Jurassic was suggesting to upgrade for the stable version of the OpenTelemetry that is on. There are some improvements in terms of resource utilizations, and this point is that we are working now to provide some improvements and get better performance on OpenTelemetry load balancer.
All right, cool.
Okay.
Thanks. Gabriel, do you have another question?
No, that's it.
And Thomas, do you have any questions to Alexander?
I don't think
All
so.
right. All right, so let's move on to Thomas. So Thomas, great presentation. And you mentioned the project Talon, which was not aware.
Yeah.
And I immediately thought about, this is it's almost like a remediation engine in Kubernetes that I can use. Can I send other type of data to? So basically, I don't have Falco, and I'm just want to basically send some events, and then Talon will stream out those events and do similar process. Example I did. So I get that event, and then I want to do I want to get the logs. I want to whatever send it here. And are you only is it only dedicated to Falco, or is it a completely independent project that could be used with anything?
It's not independent at all. It's totally intricated with Falco. Right now, we focused our efforts to be 100% compliant with Falco, but nothing else. It's not a generic solution. It's really made for Falco.
Okay. And is there a way? Is there like to expose Falco somewhere to say I want to have like I don't know. Let's say we use Ansible, and Ansible has a playbook, and he knows that Falco is there, and I want to do like a Kubernetes delete. So at the moment, there's no way of using Talon to basically do this Kubernetes delete, for example, delete pod.
We can delete pod with Talon for sure directly, and we will integrate Ansible playbook as on catalog actions. So technically, we will receive the Falco events, take the fields that are important, and then run the playbook with these inputs.
Yeah. So then you will send a request or notification to Ansible, and then Ansible will take over and run the playbook related to the event.
For Ansible, we have to run it. Basically, we need a wrapper to run the playbook at the end. So to call the Ansible function. It's not a web server listening for inputs.
And I think, I don't remember, in one slide you said you have the trace ID. So are you able to append logs to an existing, let's say that, I don't remember, I saw something about trace ID and I said, do you, so could you maybe give more details on that?
Yeah, basically, because Talon can do stuff in parallel to be sure the received events and the actions are correlated, are technically related. Each event received by Falco, by Talon, and trace ID is ejected in the payload, and the payload is then forwarded from one step to another. So the handler to receive the event from Falco, then the rule engine to compare the rules with the event, then the action, then the notification, then the output to forward the artifact created by some actioner to S3, for example. So a trace ID is created to be sure all these events are correlated. And Igor, who is working with me on the project, is integrating traces. So with that trace ID created at the beginning, we will be able to have in a single trace all actions with their start and their end made by Talon.
So which means I have, let's say, the cart service, for example. Gabriel took the cart services. So the cart services, we say get to cart, and then suddenly Falco detect that there's a suspicious event at the moment. So then Falco create at the same transaction level, say, hey, there is something wrong, something weird here, and then you can see the remediation or not the remediation, but the workflow that Talon has.
You will have the detection of the event, the match, the action with the output, the second action with the notification, and so on in the same trace.
Okay, that's really, really cool. So I will have to try it out for sure. That sounds very cool. Really cool project I was unaware. So thanks for sharing that.
It's
so
still the alpha, to be honest.
I will send
this is why
the
it's
QR
not
code
really
for those. So we were talking about Falco here, Talon. So if you, this is the QR code to reach access to it, and really interesting project, part of the Falco ecosystem. Alexandre or Gabriel, do you have any questions for Thomas?
I have one. I don't know if I understood well, but in Falco, it's possible. For example, I have my Grafana Loki, for example, storing the logs, and it's possible to connect logs in this Grafana Loki to analyze the logs that is there and provide some insights in terms of the security, or Falco taking this kind of analysis in runtime.
Falco works in a discrete mode, so it means every element is unique, no relation with the event before and after. But if you have the plugin for, you can totally collect any kind of logs you may have in Loki, ingest them in real time like a stream, and then compare them to some rules to trigger an alert.
Okay, nice. I got.
So we have a plugin to ingest any JSON you may have, so it's okay.
But I thought that Falco was you were detecting suspicious events from a kernel perspective, and then you raise a log, and that log could be ingested in Loki, no?
Any event, yeah. Any source of events, basically. At some time, we collected, just for fun, tweets in real time. So people were able to tweet with a specific hashtag, and in the UI, in the background, the tweets were showed in real time. So basically, as long as you have an event and the right plugin, you can collect this event and compare it to some rules. The first rules of events is basically the kernel with the syscall collection, but any event is possible.
That's cool. I thought it was mainly 100% related to eBPF syscall events, but I didn't realize that you were doing also external events as well. That's cool. Gabriel or Alexandre, do you have any other questions?
Nope, I'm good.
Nope. All right. So thanks, Thomas. So Gabriel, I love the prototype. Super excited when I saw it. And so first, you just shared the repo. So let's share the. Oh, here it's displayed differently. I'm sorry. So on the right, on the left top right, top left of the screen, you see the QR code to the GitHub repo to the PG trace connector. My first questions will be related to that repo. Are you going to push it upstream to the hotel contrib to share it to a larger community, so then other maintainers or users from OpenTelemetry could contribute and improve or even add more stuff inside of that?
So for now, it's a prototype. It's not very good Go code. It's really just to try it out if it works, and I will see if we will use it in our company. It could be that we start to use it, and then if there's interest from people, so let me know if you're interested in seeing this. Then I can further develop it, improve on it, and also do it in public here. And I can also try and add it as a contribution to the contrib repository of OTel Collector.
That would be amazing for sure. And I had another question.
Everybody, let me know.
I had a questions about the connector. The connector. So you rely on logs. So I guess you're configuring PostgreSQL to generate lots of logs. So the extended log version provided by Percona, I guess. So you use the Percona component to do that. You're just when you started, so yeah, generates all the execution plan with the logs of that. So how do you enable this?
So you can configure. PostgreSQL has the capabilities to log this stuff out of the box. It's a couple of log settings that you need to find and tune correctly, and then you can do it. I have done it also in a Docker repository. I can maybe also share that, and so it's basically out of the box PostgreSQL, and then I just needed to ensure that I can write JSON logs and write it to the standard output. But it's nothing, no magic. There's no Percona stuff in there. But there are a lot more logs generated now than out of the box
than before. And the other thing is, I remember when playing with the commenter, is that the actual execution plan and detailed, you didn't have it for 100% of the queries, because obviously you want to sample it because there were a lot of processing involved. Here, is there already like a pre-default sampling decision made with this solution, or whatever query comes in, it will be sent to the collector, will grab that log and start processing it?
So right now there's no sampling. All the queries are being logged, sent to the connector. We get query plans for all the queries, even the internal queries that PostgreSQL uses to just do some vacuums and stuff, take care of itself. So lots of query plans that we get, but there is the capability also in PostgreSQL native to do some sampling and just sample like once 1 in 10 or 1 in 4 queries using this method.
Cool. Awesome.
It can all be configured on the PostgreSQL instance.
Of course. That's really interesting. So, Alexander or Thomas, do you have any questions to Gabriel?
That was mine either. He just answered what I was wondering. So.
All right. So, Gabriel, I really loved your. I will have to try, to be honest. I will have to play with it to because I think it's a really interesting initiative, and I think a lot of people should love it, because the downside of SQL Commenter is like you were pretty much linked to Cloud SQL, which is quite a bummer for sure. So you just sent a link. So SQL tracing, it's another from so there's another project interesting.
This is an example application with it's the whole setup with OpenTelemetry and the container, the PostgreSQL container. You can have a look in the repository how to configure the PostgreSQL, for example, to do all this stuff. It's all documented in there.
All right, cool. Thanks for sharing. All right, so I think we were a bit above the actual timing for the live stream, but I thought it was interesting topics. I had some questions. I'm sorry about that. So thanks, Thomas. Thanks, Alexandra. Thanks, Gabriel, for taking the time to join and present those topics and take the time to prepare those demos. So really appreciate it, and really interesting topics for sure. So thanks, and I will conclude this sessions and yeah, thanks, and see you probably soon for another a conference, I guess.
Yeah. Thank you.
All right, so that's it for this Observable Lightning Talks of June 2024. A lot of great topics, insights. Gives me a lot of idea about taste sampling, a lot of idea about the SQL tracing. That was really interesting, and also the Falco and Talon project give me a lot of insight. So let me know if you had interesting if those presentation gave you some ideas, or if you want to try it out. Drop a comment below. So then we can maybe do a more deep dive on those solutions in the channel. So thanks for watching, and if you enjoyed this live stream, don't forget to like and subscribe to the channel. So see you soon for another Observable Lightning Talks.